Square roots of variable expressions. It's not really that hard. It's not that different, okay? Let's look at example number 1. It says simplify here, okay? Now they want the positive and the negative, so I know that my answer is going to be plus or minus. I'll just write that over there right now. I know that they want both of those, okay? And let's see. You know what? Let's try to reduce this and see what we get. 256 over 400. I know that 2 goes into both of them, right? 128 over 200. All right, I know 2 goes into both of those. That's going to be 64 over 100. Okay, I know that 2 goes into both of those. That's going to be 32 over 50. Good. I know that 2 goes into both of those. That's going to be 16 over 25. And I think that's it. Okay, so now I've got plus or minus the square root of 16 over 25 s to the 12th. Okay, now remember, whenever I'm taking the square root of a fraction here, right, this is going to equal the square root of 16 over the square root of 25 s to the 12th. Okay? Well, the top one's easy, right? I know that that's going to be 4. I also know, right, that I can multiply radicals. So I know that on the bottom I've got the square root of 25 times the square root of s to the 12th, right? I can separate them that way. Okay, well, let's think about this. It's getting simpler here. So now it's 4 over 5 times the square root of s to the 12th. Now let's deal with that. Okay? What's the square root of s times, well, wait, what's the square root of s squared? Well, it's the square root of s times the square root of s. And I know that a pair of them gives me s, right? Okay, well, let's think about this. The square root of s to the 12th is equal to root s, 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 root s. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? This pair gives me s. 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 That pair gives me s. S to the 6th. Okay? Now, a simple little rule for this. Well, let's go ahead and write the answer then. It's going to be 4 over 5s to the 6th. And they wanted the plus and the minus. Okay? But a simple rule here is to divide the exponent by the root. Okay? So if you've got the square root, right, you've got the square, I'm sorry, hang on. If you've got the square root of x to the 14th, that just equals x to the 7th. Because 2 root x's give me an x without a root. Okay? That's pretty clear, straightforward there. Now listen, if I have an odd root, let's say I've got the square root of t to the 15th. Well, remember, that's the square root of t to the 14th times the square root of t to the 1st, right? That would give me t to the 15th. Well, this is just t to the 7th times root t. Okay? It takes a pair to get them out from under the radical sign. Okay? All right, let's look at the next one. N squared equals 64. Easy. Easy. Whatever I do to one side, I have to do to the other. I don't want to know what n squared is. I want to know what n equals. So I take the square root of this side to make it n, and I take the square root of that side, and that equals 8. You get half credit. Because remember, we talked about this earlier. Whenever I take the square root of a variable, I have to give the positive and the negative. Because positive 8 squared gives me 64, right? 8 squared equals 64. But negative 8 squared also gives me 64. Okay? So you've got to remember to give both of them. All right? Nice. Nice. We're rolling. Let's look at the next one. Find both roots of each equation to the nearest tenth. Guys, you know how to do this. Add 204. Get the variable by itself. Right? So now I've got W squared is equal to 204. I'm going to take the square root of this side, the square root of this side. They said to the nearest tenth. That means I'm using my calculator. So W is going to equal plus or minus, because I'm taking the square root of a variable. All right, let me see. I don't know. It's going to be something less than 15, because that would be 225. All right, they said to the nearest tenth. I got 14.28285686 to the nearest tenth. That means that W is going to equal approximately, not equal, but approximate, positive or negative, 14 point, you got it, 3. Because 8's bigger than 4. Remember, if the number outside the gate is 5 or bigger, then the number inside the gate goes up by 1. All right, nice. Another one done. Let's look at another one. Solve. Find each answer to the nearest tenth. Okay, I'm using my calculator. Use 3.14 for pi if I need to. A calculator may be helpful. I think it will be. Find the length of a side of a square whose area is the same as that of a rectangle 24 by 30 centimeters. Okay, so I've got a rectangle that is 24 by 30 centimeters. Okay, so the area, of course, is base times height. I don't know, 24 times 3, 720. I'm guessing. Okay, and that's going to give me 720 centimeters squared. Now, they said that we have a square that has the same area, 720 centimeters squared. Okay? Well, the thing I know about squares is that their sides are equal. And to find the area of a square, I multiply the base times the height. So x times x, or x squared, has to equal 720. I'm going to take the square root of both sides because they want to know what the length of a side is, and they said to round it to the nearest tenth, so I'll use my calculator. All right? So x is going to equal, or approximate, come on, Mr. C, get that straight. X is approximately, let's see, root 720 plus or minus, it says 26.83, so that just means it's going to be 26.8 centimeters. Now, Mr. Cortez, you can't have a side that's negative 26.8 centimeters. Hey, you know what? You're right. So get rid of that negative sign. X is approximately 26.8 centimeters long. There you go. Looking good. Man, I want to do some more. I hope I've got another example here. Yeah. Wait. Okay, only one more. All right. James, you should be happy. I'm flying through these things, and it's making sense, or it should be. Example 5 says solve. Find each answer to the nearest tenth. I'm going to use a calculator. Use 3.4 for pi if I need to. A circle inside a square just touches its sides. Okay, let's see. I'm going to use my nifty smartboard here. Here's a square. Okay. Okay, let me do this. All right. Now I'm going to draw a line so that I can get a piece of information that I need from it. Okay. I need this dot right there. Okay. Get rid of that. Get rid of that. I needed to find the exact center of that circle because that's where I'm going to put, of that square, because that's where I'm going to put my circle. So that it just touches the outside of the square. Mr. C, it's awesome. A circle inside a square just touches its sides. If the area of the circle, you mean A equals pi r squared, is 349 centimeters squared, 341.9 is equal to 3.14 r squared, because they said use 3.14 for pi. What is the length of the side of a square? Well, hey, let's divide this side by 3.14 and this side by 3.14. And let's see what we get. All right, let's see. 341.9 divided by 3.14 Oh, okay. Wow, really? All right. So that's going to give me, and don't round until you get an answer. Okay? That cancels, that cancels. I'm going to get r squared is equal to 108.88535503. Now that's what r squared equals. Take the square root of both sides. Do I need the negative also for this one, Mr. C? No, because it's a circle. I can't have a negative radius. So square root of 108.88535503. All right, so that means that the radius is 10.43481.434. Okay, that's how long this is. But wait a minute, the side of the square is this and this. So if I multiply that by 2 times 2, I'm going to get that side of the square, right? X is going to equal 20.8696286. All right? And it said round to the nearest 10th. So I'm going to put my gate around that, and I'm going to get that X is equal to 20.9 centimeters. How about that? That's some nice looking math. Looks like we know something. We know better, but it looks like we know something. That's fun. All right, I'm just going back. I want to make sure that I covered everything that I needed to cover before you guys move on. Okay, all right. I like it. Good job. And I think you're ready. Okay, guys, good luck.